Chapter 1.6.3 Projected Volumes. Kubernetes projected volumes are detailed in this document, highlighting the importance of familiarity with volumes for understanding. Introduction. The text describes how a projected volume can map various volume sources such as secrets, downward API, config maps, service account tokens, and cluster trust bundles into the same directory. These volume sources must be in the same namespace as the pod. The text provides examples of configurations for projected volumes using secrets with non-default permission modes. Each projected volume source is listed in the spec under Sources, with parameters mostly the same except for changes in the secret name field and default mode. Service account token projected volumes. The text explains how to inject the token for the current service account into a pod at a specified path. An example pod is provided with a projected volume that contains the injected service account token. This token allows containers in the pod to access the Kubernetes API server using the identity of the pod's service account. The audience field in the token specifies the intended recipients and their identifiers with a default value of the API server. The expiration seconds field sets the duration of validity for the token, with a default of 1 hour. Administrators can set a maximum value for token expiration as well. The path field specifies the relative path to the mount point of the projected volume. It is important to note that containers using a projected volume source as a subpath mount will not receive updates for those volume sources. Cluster Trust Bundle projected volumes. Kubernetes v1.29 introduces a new feature called Cluster Trust Bundle, which allows the contents of one or more Cluster Trust Bundle objects to be injected as an automatically updating file in the container file system. To use this feature in Kubernetes 1.31, support for Cluster Trust Bundle objects must be enabled with specific flags and gates. Cluster Trust Bundles can be selected either by name or by signer name, with options to designate a single object or a set of objects with the same signer name. The kubelet normalizes the certificates in selected Cluster Trust Bundles, reorders them, and writes them into a file in the container file system. By default, the pod will not start if the named Cluster Trust Bundle is not found or if the signer name label selector do not match any Cluster Trust Bundles. The optional field can be set to true to allow the pod to start with an empty file at the specified path. Security Context Interactions. The text explains the proposal for file permission handling in projected service account volume enhancements for both Linux and Windows containers. In Linux pods, the projected files have correct ownership set when run as user is specified in the pod security context. The kubelet ensures that the service account token volume is owned by the specified user and has the correct permissions. Ephemeral containers added later do not change the volume permissions set during pod creation. In Windows pods, ownership enforcement is not possible due to the way user accounts are managed in Windows. Each container maintains its own instance of the SAM database, making dynamic configuration of file ownership by the kubelet impossible. It is recommended to place shared files in their own volume mount outside of C to avoid potential security issues. By default, projected files in Windows pods have specific ownership settings that grant different levels of access to administrator and non-administrator users. Using run as user in the security context for Windows pods can cause the pod to be stuck in container creating indefinitely, so it is advised not to use this option with Windows pods. Overall, granting container access to the host should be done cautiously to prevent security exploits.